the moon disappears. Not gradually, not behind a cloud. It simply vanishes, gone from the sky in an instant. No warning, no explosion. One night it rises like always, and the next it doesn't. People look up in confusion. No glow, no crescent, no sliver of silver in the darkness, just emptiness. At first it seems like a strange anomaly, maybe a rare atmospheric effect, or a technical glitch in astronomy tracking systems. But soon, observatories confirm the unthinkable. The moon is no longer there. No reflection, no orbit, no gravitational signature. It's not behind the Earth. It hasn't gone dark. It's gone. And while the sun is responsible for life itself, the moon plays a much quieter, yet essential role in Earth's balance. So what happens next? The consequences unfold faster than anyone imagines. Within the first hour of its disappearance, the tides, one of the most immediate and visible effects, begin to change. The moon's gravity pulls on Earth's oceans, creating the high and low tides we rely on daily. Without it, the tides weaken drastically. Coastal regions that experience dramatic tidal movements, like the Bay of Fundy or parts of Indonesia, suddenly find themselves with unusually still waters. The ebb and flow that fishermen, marine ecosystems, and coastal industries rely on begins to fade. But the real danger is not the disappearance of tides. It's the chaos that follows. The moon has acted as Earth's gravitational stabilizer for over 4.5 billion years. Without it, Earth's axial tilt becomes vulnerable. Currently tilted at about 23.5 degrees, this angle gives us our seasons. But without the moon's gravitational pull, the tilt becomes unstable, wobbling over long periods, potentially swinging from near zero to over 85 degrees. That would cause catastrophic shifts in global climate over millennia. Some regions could go from icy tundra to scorching desert and back again. But even before such long-term changes occur, short-term disruptions begin to surface. Animal behavior shifts within days. Many species, from sea turtles to birds, rely on the moon for navigation, mating cycles, and biological rhythms. Coral reefs, which spawn during full moons, suddenly lose their natural timer. Migratory patterns begin to falter. Some animals become disoriented, others become vulnerable to predators. Entire ecosystems start to unravel in subtle but irreversible ways. Humans too feel the impact, not just in our science or technology, but in our minds. The moon has been our companion for all of history, a constant in myth, art, and religion. Its cycles mark calendars and rituals. Its phases influence sleep patterns. Its absence triggers something primal in us, a deep, unsettling sense that something fundamental is broken. Psychologically, societies react with a mix of denial, superstition, and panic. Conspiracy theories flood the internet. Governments issue official statements. Telescopes point at the sky in vain. But the result is always the same. Nothing. No moon. Just stars. And then come the aftershocks. Not from within the Earth, but from space. The moon shields Earth from many asteroid impacts. It acts like a gravitational sponge, catching or redirecting space debris. Without it, Earth becomes more vulnerable. Within months, astronomers report more near-Earth objects coming dangerously close. The moon's absence leaves a gravitational vacuum, slightly altering the paths of thousands of celestial bodies. Weather patterns begin to shift as well. Without the stabilizing effect on Earth's rotation, some scientists report subtle changes in jet streams and ocean currents. Storms behave differently. Some regions become wetter, others drier. Over time, these minor shifts could compound into global weather instability. 1 year after the disappearance, the long-term consequences become clearer. Earth's axial wobble increases slightly. Seasons begin to drift. Coastal ecosystems, tuned for tidal motion, start to collapse. Populations of crabs, mollusks, and coastal fish decline. Human industries tied to these systems suffer economic hits. But perhaps the greatest loss is symbolic. We have lost our nightlight, our silent guardian, the celestial mirror that once watched over Earth. The moon's disappearance is not just a scientific event, it's a rupture in human history. And it all began when someone looked up and saw nothing. In the days following the moon's disappearance, Earth's skies begin to change in unexpected ways. Nights grow darker, truly profoundly dark. Without the moon's glow, the sky becomes an abyss, lit only by the distant, cold shimmer of stars. For the first time in millennia, human eyes adjust to a world without lunar light. Cities remain lit by artificial means, but rural areas, deserts and forests plunge into an inky blackness that affects everything from human activity to predator-prey dynamics in the wild. For some, this new darkness brings awe. The Milky Way becomes visible with stunning clarity. Stargazers rejoice in skies free from lunar interference. But for others, the darkness becomes oppressive. Emergency services report increases in accidents, nocturnal crimes, and psychological disturbances. Sleep disorders spike. Some people report nightmares, night terrors, and even lunar withdrawal, an informal name scientists give to the strange unease people feel in the moon's absence. Meanwhile, the Earth begins to wobble. Without the moon's gravitational pull, Earth's axial tilt becomes increasingly unstable. Although this wobble won't cause massive seasonal shifts immediately, computer models show that even a few degrees of change could result in dramatic climate events over time. Deserts may turn into jungles, ice caps may melt or expand unpredictably. Weather patterns shift. Monsoons arrive out of season. Droughts strike unexpected areas. Farmers lose predictability. Food systems begin to feel the strain. The oceans too respond with eerie calm. Without the moon's tug, the tides become dictated mostly by the sun, still present but far less influential. High and low tides become shallow, sluggish. Coastal communities that once timed their fishing and trade to the rhythms of the sea now struggle with unpredictability. The great oceanic gyres, those massive spinning systems of currents, slowly begin to lose their shape, subtly altering the distribution of nutrients and marine life. Animals continue to struggle. Insects that use the moon to navigate become lost. Hatchling sea turtles emerge on beaches and crawl in the wrong direction, mistaking streetlights for lunar guidance. Nighttime hunters like owls and wolves adapt to the deeper darkness, while prey species face higher predation rates. Entire food chains begin to shift in response. Astronomers, desperate for answers, scan every inch of the sky. Radio telescopes listen for anomalies. Space agencies run simulations. Was this a natural event? A cosmic anomaly? Or something else entirely? The most disturbing realization: no debris, no explosion, no impact. The moon didn't break apart. It didn't crash into Earth or drift out of orbit. It simply vanished. No gravitational ripple, no light echo, nothing. This leads some to speculate about advanced extraterrestrial interference. Others fear an unknown cosmic phenomenon capable of removing celestial bodies without warning or trace. Theories range from alien harvesting to black hole phenomena to temporal distortions in space-time. But no evidence supports any single idea. Meanwhile, human culture begins to adapt. Artists depict the moon's absence in paintings, films, and music. Children grow up never having seen a full moon. Calendars that once relied on lunar cycles become irrelevant. Religious ceremonies shift. New superstitions are born. The moon, once taken for granted, becomes a symbol of loss and mystery. As Earth continues to drift into a new normal, the question remains, is this permanent? Some scientists warn that the consequences of losing the moon will not be truly felt for decades, even centuries. Others focus on practical problems: how to stabilize Earth's axial tilt artificially, how to restore tidal motion using satellite arrays or artificial moons, how to adapt ecosystems through biotechnology and intervention. But for now, the world holds its breath. Without the moon, Earth is still here, but it's not the same. We've lost our compass, our calendar, our protector, our poetic mirror in the sky. And though we may survive, we do so with the constant awareness that something fundamental is missing. The silence above is no longer peaceful. It is a question, one that echoes across the void. Weeks after the moon's disappearance, Earth's delicate balance continues to shift, this time with more profound and visible consequences. One of the first major impacts unfolds in Earth's oceans. Without the gravitational stabilizer of the moon, the tidal system begins to fall into disarray. The sun alone now drives the tides, creating smaller, erratic shifts that follow different cycles. Coastal ecosystems, delicately tuned to the rhythm of high and low tides, begin to unravel. Coral reefs, estuaries, and tidal wetlands suffer. Species that rely on consistent tidal flows, such as crabs, mollusks, and intertidal fish, begin to decline. Fishing industries feel the pressure. Catches shrink, migration patterns vanish, and economic panic spreads across coastal regions. Entire communities reliant on the sea for sustenance face collapse. Meanwhile, the ocean's ability to regulate climate weakens. Normally, tidal forces help mix warm surface waters with cooler deep waters, redistributing heat across the globe. Without that churn, the oceans begin to stratify. Heat stays trapped at the surface, accelerating climate instability. But the oceans are just the beginning. With no moon to stabilize Earth's axial tilt, our planet begins to experience what scientists call axial chaos. Over time, Earth's tilt starts to vary more dramatically. It doesn't happen overnight, but within months, slight changes begin to affect seasonal weather. Winters grow longer in some regions, shorter in others. Rainfall becomes unpredictable. Crops fail unexpectedly. In equatorial areas, droughts begin. In temperate zones, violent storms erupt in what used to be calm seasons. Climate refugees become a reality. As certain regions become uninhabitable due to failed agriculture or extreme temperatures, populations begin to move. Border tensions increase. Governments are forced to adapt quickly to manage resources, food and water. Space agencies now turn their attention to artificial solutions. Proposals include the launch of massive satellites equipped with light reflectors and gravimetric stabilizers, essentially synthetic moons. These devices aim to replicate tidal influence and reduce axial wobble. But such mega projects require global cooperation, billions in funding and decades of implementation. Still, the race begins. On a more immediate scale, the effects on human psychology are profound. The moon has always been more than a celestial body. It has served as a symbol, a comfort, a constant. Its cycles are tied to our sense of time, sleep, and cultural memory. With it gone, humans report increased rates of insomnia, anxiety, and depression. Night feels more threatening, more infinite. Artists and writers speak of sky grief, the emotional toll of losing the only satellite we've ever known. Religions, too, begin to fracture and reform. In many cultures, the moon has held spiritual significance for thousands of years. Its disappearance sparks theological crises. Is this a divine punishment, a test, or a message? On the scientific front, new questions emerge. Without the moon's protection, Earth becomes more vulnerable to asteroid impacts. For billions of years, the moon has acted as a cosmic shield, absorbing or redirecting debris that might otherwise strike Earth. Now, space agencies are forced to accelerate the development of planetary defense systems, lasers, kinetic impactors, and deflection satellites. The first close call comes just 2 months after the moon vanishes. An asteroid the size of a stadium passes within 20,000 kilometers of Earth, closer than some satellites. Had it struck, it would have destroyed an entire city. The world realizes how much silent protection the moon once provided. And then comes a second existential threat. With no lunar tidal friction to slow Earth's rotation, the planet begins to spin ever so slightly faster. The change is minimal at first, fractions of a second shaved off the length of a day, but over years it will add up. Shorter days affect human biology, plant cycles, and digital systems dependent on synchronized timekeeping. Atomic clocks have to be recalibrated. Agricultural calendars must be rewritten. Our sense of time is literally changing. But perhaps the most surreal consequence of all is cultural. The moon has inspired myth, art, romance and science since the dawn of humanity. It was the goal of the space race. It was the subject of poetry, the object of longing, the backdrop of countless nights. Now it's a memory. Museums dedicate entire exhibits to it. Music shifts toward darker, more melancholic tones. Filmmakers explore themes of loss and cosmic loneliness. Children born after the moon's disappearance grow up with no reference for what a full moon even looks like. And yet humanity adapts. Lunar simulators are developed, large light panels in rural regions to mimic the moon's presence in the night sky. Some communities project artificial moons for cultural or psychological comfort. New holidays emerge to commemorate the night the moon disappeared. Despite the chaos, there is resilience. But the question lingers in every scientist's mind, every philosopher's meditation, and every child's bedtime question. Where did it go? And could something take Earth next? Months have passed. The Earth is still spinning, still orbiting the sun, but nothing feels normal. The moon, once our silent guardian and cosmic companion, is simply gone. No trace, no debris, no explanation. And as telescopes scan the skies in search of answers, one question haunts the horizon. If the moon can disappear without warning, what will vanish next?